Hello everyone, so we are looking at Leetcode problem longest consecutive sequence. In this problem, we are given an unsorted array of integers. For example, 100, 4, 200, 132, so it's unsorted integer array. And we need to return the length of the longest consecutive elements sequence. And it must be in O of n. So let's look at example 1. We have here an unsorted array with a few items and the output is 4. Why 4? Because we can see that we have 1 and then 2, which is consecutive, and then 3 and then 4, and that's it. So we have 4 elements here. So the longest consecutive elements is 4. In this example, we have, let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, and that's it. So the output is 9. Okay, so let's think about this problem. Let's draw a few numbers first. Okay, so we have here an array. So let's say that we have 5, 2, 8, 7, and 3, and 4. Okay, so we look at this, and the immediate things that come to mind is to sort this array. Let's sort it. But we know that sorting is O of n log n, so it won't do the trick, but we need to start massaging the problem. Okay, just like any problem in life, we need to start massaging it and thinking about it. So we start by looking at this array and we sort it, although it's not not going to solve it because they ask for O of n. So if we sort it, we have then 2 and then 3, then 4 and then 5, and then we have a jump. So we have here a jump, and then let's make it a different color on this jump. Okay, and then we have a jump to 7 and 8, and that's it. So we see that we have this subsequence, which is of size 2, and we have this subsequence, which is of size 4. So the answer here is 4. However, this is not good because sorting in the usual sorting algorithms is O of n log n, especially taking into account the restrictions that they have here, which is basically unbounded number of items. So when we have a problem that we cannot solve immediately, especially in algorithms and in problems, then usually this is what we are going to need to do. We are going to look at the constraint and then draw the target that we want. So what is the target array that we want? This is the target. This is the answer, right? So this is the target array that we want, but we can't sort it. Okay, so there is a constraint because we can't sort it. So if we can't sort it, because its time complexity is going to be much higher, and they hinted us that we need to solve it in O of n, this means that we should basically scan this array in a constant amount of time. And when we scan this array in a constant amount of time, we need to find if we have such subsequences. Let's look at these subsequences and try to understand how could we do this in O of n of time. It looks like magic. So if I look at this target array and I look at the numbers here, I see what's the obvious thing? That each of them is the number next to another. So 3 is next to 2, and 4 is next to 3, and 5 is next to 4. It's just the next number. But 2 does not have a left friend, and 5 does not have a right friend. So these are the boundaries. The boundaries that we need to find is when a number does not have a right friend and a number does not have a left friend. If the number does not have a left friend, then it's the beginning of the subsequence. If a number does not have a right friend, then it's the end of the subsequence, and same for here. How could I know if a number has a right friend, does not have a right friend, has a left friend, does not have a left friend? But taking into account that the total amount of time should be orphan. So nobody limited us in space. No space limit. Aha! If nobody limits us in the amount of space, this brings to mind immediately, the data structure of hash map and set. Especially that they are talking about an orphan of a complexity of time. This means that if I take this array and create a set out of it, 5, 2, and this is an orphan time, 7, 3, 4, this is a set, then I could immediately in orphan time tell if 2 has a right and a left friend, because I asked the set, do you have 1? No. Do you have 3? Yes, orphan. This is a set. Okay, so this looks like for now we can easily start by scanning this array. Ask for 5. Do you have a left friend? No. So you could be yes. So this means that you are not the start of a longest sequence. So I will move to the next number. 2. Do you have a left friend? No. Okay, great. You are going to be our candidate for the longest sequence. So you are number 1. Do you have a right? And now we start asking about the right friends. 2. Do you have a right friend? Yes, I have 3. Okay, great. 3. Do you have a right friend? Yes, I have 4. 4. Do you have a right friend? Yes, I have 5. 5. Do you have a right friend? No. So right now we are standing at 4. And now we could just move on to the next number here, which is 8. 8. Do you have a left friend? Yes. So let's skip you. 7. Do you have a left friend? No. Do you have a right friend? And we are asking the set all the time if they have a right or a left friend. 7. Do you have a right friend? Yes, it's 8. Okay. And in this way, and now we are at 2. So 4 is the largest, and this is it. We looked at the problem, we started massaging it, and we always start by sorting it. It gives the answer, but it's not, it's orphan and log n, and it cannot be because they asked for orphan. And then we have to note that they didn't limit us in the space complexity. And if someone does not limit you in the space complexity, use a set or a hash map. Then by a set or a hash map, and we must look at the numbers. We see that we have characteristic no left friend, yes right friend, and this is it. So, okay, so now let's move on to the coding of this problem. Okay, and now we move on to actual coding of the solution. So we have to have the set that we discussed. It's going to be a set of integer, new hash set, and then we are going to need to initialize, do all the initializing that we have on the beginning. So let's scan the input array from beginning to its length, nums.length. And for each item in this input array, we are going to add the item to the set. So add to the set nums I. Okay, so now we have the set. And now we do the same thing. We scan the array again for int I, and we check if we have the left friend or the right friend or not. So we scan the array again. Why is this smaller? Right. Okay, so we scan the array again. And for each item, we need to check if it has a left friend. If not, this means it's beginning. So check if set does not contain, which means it does not have a left friend, the current number. But not the current number minus 1, because we need to know if it has a left friend. And if it does not have a left friend, this is the beginning of the new array. So we start with a length. We already know that we have one item, so we have length 1, and then let's scan all the right friends from the set. So we check while the set contains the current number, which is nums I plus length. Okay, y plus length. If the current number was 3, then we want to check if 4 is there, and then we increment the length and check if 5 is there, and then we increment the length and check if 6 is there. And if it is in the set, then we increase the length and continue checking if it has a right friend. So length plus. And then when we finish, we know that the max length, let's initialize the max length here, max length, int max length is 0. We don't know if we have any input items. If then the max length would be the math.max of current max length and the current length that we have measured. And then just return the max length. And this is it. We have a set. We have initialized the set with all the items with set.add. In Java, set is a new hash set, this most simplistic one. To check if an item is contained in a set, we check set.contains. And to check what is the max, we use the Java function math.max and the two numbers. Okay, let's try to run this. And compile error. Set.add, let's see. Set.add nums. One. And looks good. Okay, great. So this was find the largest amount of consequent sequences in a set, in a list.